Hey everyone, welcome back to the channel. If you're new here, please subscribe and hit that notification bell so you don't miss any of our weekly uploads. Also, like the video on the way in. And with that, let's get into it. Over the last month or month and a half or so, AWS, Azure, and Cloudflare each experienced high-impact outages that disrupted services across the globe. Today we're going to break down what happened and what this really means for resilient cloud architecture and GRC. Each one of these outages may have been caused by different technical failures, but they all expose the same architectural reality. Even hyperscale cloud providers have single points of failure. Every cloud platform has global components that customers rely on whether they realize it or not. AWS has US East 1 as a home region for global services. Azure has centralized identity. Cloudflare has global edge propagators that update in seconds. These systems make the cloud powerful, but they also create centralized dependencies that are nearly impossible to avoid. From a governance, risk, and compliance perspective, these events highlight a major gap in most organizations. Companies architect for uptime, but they don't architect for failure as much as they should, and failure is inevitable. If you're responsible for cloud security, compliance, or architecture, the takeaway is simple. Resilience must be intentional. Multi-region architectures are not a luxury, they're a requirement for any organization with SLA commitments or regulatory obligations. Availability isn't just an operational concern, it's a compliance control. It's also important to understand which pieces of your environment cannot be made multi-region. AWS IAM, Route 53, CloudFront, AWS organizations, ACM public certificates, and the S3 global control plane all tie back to US East 1, whether you deploy there or not. Identity systems in both AWS and Azure are unavoidable single points of failure. DNS systems, whether Route 53 or Cloudflare, can create global dependencies even when your workloads are spread across regions. This is why designing for resilience goes beyond deploying in multiple availability zones. You have to map your dependencies, understand where global services live, and consider redundancy across providers for critical components like DNS, CDN, identity, and logging. Not multi-cloud for compute, but multi-cloud for survival. On the other hand, from a business perspective, the cost and complexity associated with multi-region, multi-cloud infrastructure can become a challenge. Building the most resilient architecture known to man may still fail, and if RTO isn't reached in minutes, your business may still make the headlines for the wrong reasons. Historically, many businesses have elected to accept the risks associated with a potential outage versus spending the extra coin to not only build but maintain super resilient infrastructure. The question now is, will these recent incidents shift the mindset of decision makers to try and build more resilient infrastructure, or will they stay the course? If you found this breakdown helpful, hit that like button and subscribe for more content like this. Thanks for watching, and remember, security starts with base. Catch you in the next one.